Hi, okay, welcome to session 11. This is our last session with learning. After that, you've completed everything that we're covering in the course, and it will be our consolidation to just finish things off. So today we are going to be looking at speed, distance, time. We're going to be looking at that in both the worded versions and in the distance time graphs that we see as well. We've got our normal recap, which I will scroll through slowly. So if you're using the screen, you have that to look at. And then I will go through and scroll through those answers. So you just sort of pause as you go and as you need to. So speed, distance, time, all right, a really important area because it not just comes up in our maths, but it comes up in our science as well. There is a formula triangle that helps us organize our thoughts and just generally make sure that we piece everything together properly. However, you do need to make sure that you get everything in the right place. So we've got the formula triangle, distance goes on the top, and then you've got your speed and time, and it really doesn't matter which way round you do that. And a really easy way to remember that is alphabetically. You know, D is in the top of the triangle. It's the first letter in the alphabet. It's fine. It's a perfectly good way. However, we also have a topic called mass, density, and volume. And obviously there's a D in that. And then the temptation is to obviously put that in the top, which is completely wrong. So I shy away from doing it alphabetically for that reason. I see that as a sort of common error that pops up and happens. So we've got to be a bit careful of that. So one of the ways that I have helped students remember, it's really stupid and you could kind of come up with your own thing, is actually, let me bring that mass, density, volume back a sec. I think about it like it's mum and dad, okay? If I've got mum, then mum is in charge. She's on top. So the correct triangle would be to have mum. And then obviously you've got your D and your V, any order you like, but mum's in charge, okay? Don't tell any dads I said that. And then obviously over here, we don't have mum around, so dad has to take the reins and he's now in control. So that's a way. It's a silly way, but it's a way that may make a difference and may help get those letters in the right place, okay? So speed, distance, time is used in a triangle formula to help us know what to do with the numbers. It tends to be used more for the wordy questions rather than the graphs, although it fits there, and I will make those links so that you can see it as well. Okay, so speed is found by doing distance divided by time. Okay, distance divided by time. That's what the triangle is trying to tell us. Okay, now if we think about distance, distance could be given in miles, time could be given in hours. And now think about your units for speed. They are miles per hour or miles per hour. So it's all connected, it's all linked, and I hope you can kind of see those links. If I show you a distance time graph, and I'm just going to obviously sketch this out, they're just notes at this stage, aren't they? Distance is always along there, time is always along the bottom, and then the graph shows the journey. Okay, this here, when you have some steepness to a line, we call that gradient. Gradient is the topic y equals mx plus c. So if you've done that topic, that will mean more to you than if you haven't. If you haven't done the topic, then you don't really necessarily know that gradient, which measures how steep a line is found by doing the rise divided by the run. Now, the run is your x-axis. Our x-axis happens to have time on it, but your run is that horizontal. You're not going to run up a wall. You would run along a flat though. So that's our run. And our rise is our y-axis, which happens to be d. Okay. So you can see, again, the links with the gradient. If you find it by doing rise divided by run, which in our graph, the rise is d, the run is t, you've got that d over t happening. Okay. We've got dt happening, but look over here. Speed is equal to distance over time. We're saying the gradient is distance over time. So in this situation, my gradient is actually showing me my speed. So now in this type of story, I won't say as the gradient gets bigger, steeper, I get a bigger number. Here, I will go as my line gets steeper, my speed is getting faster. So that's one way of looking at the graph and being able to see two different lines and know which part of the journey was quicker than another part. So there's a lot of maths, cross-topic and links being made there. We don't need to be completely secure in all of that. That's just because I really like you to have that understanding behind why we do some of the things that we do. Okay, so let's get going. We are going to have a little look at time just for a moment, because time can be a tricky little sucker. They pop it in certain ways that literally lead you into making certain errors, okay? So for example, if I've got the question given to me in hours and minutes, let's say they've given me 1 hour and 30 minutes, they've given me that in my question. What they've actually done is given me two completely different units. And I can't work in two different units. I can only work in one unit, which means I am going to have to either change the whole thing to minutes or change the whole thing to hours. And this again is where you need to take a good look at that question. If the question says give your answer in miles per hour, you have to work in hours. There's no point in working in minutes. And quite often you are asked for it in hours. So you have to know the decimal equivalent. And the most common thing we see is that. All right, so that's why I'm making a kind of big deal about this, so that you are aware of how completely wrong that is. 30 minutes is half an hour. If I asked you to write a half as a decimal, you wouldn't write 0.3, you would write 0.5. So in our haste, when we're asked to change this into hours, it's really common to see that. So we need to stop and think and remember that actually it would be 1.5. And they can obviously use different units. It doesn't have to be 30 minutes, does it? You know, different parts of time. If they'd done 15 minutes, that would be 0.25 and so on. So you do need to be just mindful of that and just take real care. So that was kind of all the notes, all the information that I want to pass on about when you're using that triangle. The easiest way to do the triangle is to just get stuck straight in with it. As long as you know exactly what you're doing, which is you draw it, you put dad on top or D, and then if they want the time, okay, so if they want that, you will be doing distance divided by speed. If they were asking you for distance, then you would be doing speed times time, because these are sort of squashed together, aren't they? Okay, you will have an opportunity to practice that. what we're going to do is quickly look at the distance time graphs, make sure that they're okay as well, and then you're good to go. All right, so this is a distance time graph. It has distance and time on the axes. It can be referred to as a travel graph. You'll hear the word sort of journey being used as well in the story, and they will ask questions. So you have to be able to interpret and read the graph. So this one is work out Rachel's speed in the first 30 minutes, and then you've got to give your answer in miles per hour. So if we have a look, we've got 30 minutes here, and distance is 20. So this is what we're going to be using to help us, okay? So we can see that in 30 minutes, she has traveled 20 miles. Now, if I'm going to be using my speed distance time, so let's just do that. All right, we had to work out the speed. So my distance is 20. My time is 30 minutes. I need to be mindful that I need that in hours. So I've got 20 divided by 0.5 because I want half an hour going in there. And that would give you 40. And it works, and there's nothing wrong with that. But quite often with the graphs, they are far, far easier to just kind of work with rather than worry about that formula. Because if we go back to this, if 30 minutes is 20, then an hour, which is double, is going to be 40 miles. And so you've got 40 miles per hour. You obviously need to make sure you've got that one there per 1 hour. So you can see how much easier it is to just use the graph than the formula triangle. But you've got options. If the graph wasn't showing it clearly enough, then obviously the triangle would work a treat, wouldn't it? So the next question is, Rachel spends 20 minutes at the shop, and then she travels back at 60 miles per hour, and you have to complete the time graph. Okay, well, if she's traveling at 60 miles per hour and she has only a distance of 20 to travel, yeah, she is 20 miles away from home, we've got to consider what she could travel in that distance, okay? Now, again, you could do your speed distance time. You could say, should we do it so that we can see everything? Distance, speed, time. We want to know the time so that we can complete the travel graph. So the distance is 20, okay, over 1 hour, which will give us 20, obviously. You could think of it as 60 miles, an hour is 60 minutes. It's equaling the same thing, isn't it? So we've got to see that she is at 50. It's going to take her 20. So it's going to take her to 70. And then we draw, and hopefully it works, draw that line up. So I'm trying to show you a couple of ways at the same time, and I hope that isn't confusing. The speed distance triangle works. That's what it's for. It's a formula. It will always work. But sometimes you can just use the graph and the information to make it a little bit easier. And you have to kind of go with whatever the question is and how you feel about it. So let's do another question. Oh, there you go. I drew it on in case my software wasn't working very well. Okay, here is your have a go question. Okay, so I really want you to just go for this. And press play when you're ready. Okay, so one of the things that I would do first with this is checking with the scale. The way that the scale is working will vary from question to question, and I need to make sure before I really worry about the questions that I understand how each graph is working because they will be different. Now, the time, I can see that that is an hour or 60 minutes. And I can see that I've got 10 squares. So I know that 10 little squares is equal to 60 minutes, which means one little square is equal to 6. So now when I'm being asked questions and I'm having to look at a couple of little squares, 3 squares, 5 squares, I can interpret it a lot easier. I always check both. So I would check in with this as well. That's taking, it's going up in 5s, which means every line is going up 1. So that's a nice straightforward one. So I've done the answers ahead just to make sure I don't make any silly mistakes. And well, it's not me making mistakes. I mean the getting that line in, because you know it likes to throw itself off, doesn't it? Anyway, I digress. So the distance that Henry left home, well, I can see that these are going up in hours. So half of that is half an hour. So that would be 9:30. His distance, at 10 o'clock, you go up, hit the line, come across, and that's where you get your 11 miles. Now, the hour and 18 minutes for this question, the hour is really easy to see because you've got that bit there. And then you've got your 3 little extra squares that you need to add in. And each square we know is 6, 6 3s is 18. So that all comes together by looking at it in kind of sections almost. And then the last bit, he's arriving home at 12:48. So I know that this is 12:30. So add on 6, 36, 42, 48, and that's where I needed to come in. 2 squares before 1300. All right. So if you got that right, really well done. They are very similar once you get going. Really, it's more the scale than anything else where it can change that you just need to be mindful of. So what you're going to do is you're going to have some practice. The first part of the practice is the distance time graph. And then the second part is going into the worded questions. I don't want you to panic because we haven't done a whole load of practice. We've talked about all the essentials and it's just literally popping it into that triangle and going with it. So I'm going to disappear. I'm going to scroll through everything nice and slowly and then the answers as well so that you can practice at the pace that is right for you, pausing and going. And obviously you can work on the printable if you've got that. All right, I'm going to disappear in case I get in the way. And I will see you next session where we round up everything that we have done in one huge consolidation. All right, well done today.